Have you ever stopped and thought about what it would take to cram an entire data center's worth of AI power into something you could hold in your hand? We're talking about giving robots, drones, and all sorts of smart gadgets a brain of their own, letting them think and make split-second decisions, no cloud connection needed. It's a fascinating challenge, so let's get right into it. And that really is the central question, isn't it? What does it actually take to give a machine its own brain? I don't mean just a link to some server miles away. I mean a powerful, independent mind that can see and understand the world around it, right here, right now. That's the puzzle we're going to unpack. You know, this whole idea has a name, AI at the edge. And it's not just some buzzword, it's a full-blown revolution. We're moving artificial intelligence out of those massive data centers and putting it right inside the devices that move through our world. And for a lot of these applications, this isn't just a nice to have, it's absolutely critical. And here's where the rubber really meets the road. Just think about it. An autonomous robot in a busy warehouse. It can't afford to wait for a signal from the cloud to dodge a person or another machine. Or what about a smart tractor out in a field, where internet is spotty at best? Same thing for a security system analyzing crowd flow, or a telehealth device helping a doctor in a hospital. All of them have to see, think, and act in the blink of an eye. So how on earth do you solve that kind of massive computing problem in a tiny package? Well, that's where NVIDIA's Jetson Orin comes into the picture. It's purpose-built to be that compact, super powerful brain for these intelligent machines. So let's take a closer look at the hardware that makes it all tick. And there it is. This little box is the Jetson AGX Orin 64GB developer kit. But seriously, don't let the size fool you. What you're looking at is a beast of a system that can run multiple super complex AI models all at the same time. And the fact that it's so small is key, right? That's what lets you build it into everything from delivery robots to cutting-edge medical gear. Now, if you want to get a sense of its power, just look at this one number, 275 TOPS. TOPS stands for trillion operations per second. That is a mind-boggling amount of number-crunching power. To put it in perspective, that's about 8 times more powerful than its predecessor, the Jetson AGX Xavier, which was already a monster. This is the kind of raw horsepower you need to do AI in real time. Okay, so what's under the hood? Well, the heart of it is an NVIDIA Ampere GPU with over 2,000 CUDA cores doing all the heavy AI lifting. Then you've got a 12-core ARM CPU handling everything else. But here's the real game changer, 64 gigabytes of unified LPDDR5 memory. Having the CPU and GPU share one giant, super fast pool of memory like that, it's the secret sauce for running these enormous AI models without choking. And look at the power. It can sip as little as 15 watts or ramp up to 60. That's efficiency. But look, any developer will tell you having the world's greatest hardware is only half the battle. You absolutely need an equally powerful software stack to actually unlock all that potential. And for the Jetson family, that software is called Jetpack. You can think of Jetpack as the universal key that turns the Orin from just a piece of silicon into a full-fledged development platform. It's a complete software development kit, an SDK, that gives you the whole shebang, everything you need to build and deploy your AI apps. The entire point is to help you get from an idea to a working product way, way faster. And this really breaks down how it's all put together. Jetpack is basically built on 3 pillars. First up, you have Jetson Linux. That's your foundation, the operating system, based on Ubuntu with all the drivers ready to go. On top of that, you have the Jetson AI stack. This is where the magic happens, with all the specialized NVIDIA libraries like CUDA and TensorRT that make your AI workloads fly. And finally, you have Jetson Platform Services, which are like pre-built toolkits to get complex stuff like generative AI up and running even quicker. All right, now for the fun part, let's really push this thing to its limits. The next big frontier for edge computing isn't just about spotting objects or navigating a room. It's about running those massive large language models, the LLMs, that power things like ChatGPT, but doing it all locally, right on the device itself. And that really is the multi-billion parameter question, isn't it? Can a compact, low-power device like the Jetson Orin seriously handle the insane memory and processing demands of these giant AI models completely cut off from the cloud? Well, the answer is yes, but it comes with some really interesting trade-offs. This table just lays the challenge out in plain numbers. I mean, look at this. A model like Llama 3.1 with 8 billion parameters needs over 16 gigs of memory just to breathe. Jump up to a 23 billion parameter model, and you're eating up a whopping 47 gigs. All of a sudden, that unified 64 gigs of memory on the Orin doesn't just seem nice, it seems absolutely essential. And check out that last one, the DeepSeek model. It's using a clever trick we're about to talk about to squeeze its 32 billion parameters into just 34 gigs. So how do you get this thing to perform well? Well, one of the biggest tricks is called batching. This chart shows that as you increase the batch size, which is just the number of requests you process at the same time, the overall throughput, or tokens per second, goes way up. For this Llama model, just by jumping from a batch of 32 to 128, the performance gets an 80% boost. This is exactly how you make a tiny device punch above its weight and act more like a big server. But of course, there's always a trade-off. This shows what happens when you make the sequence length longer. That's basically how much text the model has to chew on at once. As the text gets longer, going from 128 tokens to over 1,000, the throughput drops. It makes sense, right? The model has way more context to think about for every new word it creates, and that just slows things down. And that brings us to a super important technique called quantization. This is the magic trick for squeezing a giant model into a smaller space. Instead of using bigger, more precise 16-bit numbers, you use smaller 8-bit numbers. It can slash memory usage almost in half. But here's the wild part. On the Orin, for smaller models, this can actually make things slower because of some extra processing that has to happen. So you're in this constant balancing act between saving memory, keeping your speed up, and not losing too much accuracy. It's fascinating. Okay, so all this theory is fantastic. But what does it actually mean for the engineers and the developers who are out there building real products with this stuff? Let's bring it back down to earth with some practical, real-world issues. Now, this quote here, it's pulled right from an NVIDIA developer forum. It seems so simple, but it is a huge deal. A developer was asking if they could swap out different Orin modules because of supply chain problems, and the answer was a simple, direct yes. That kind of compatibility is absolutely golden in the real world. It gives teams the flexibility they need to actually get their products built and out the door. And that brings us full circle. We started with a question, and we end with a new perspective. We now have these little devices that can put honest-to-goodness supercomputing power right at the point where decisions have to be made. This isn't just a small step forward, it's a massive leap in what's possible. So the final question really isn't if we can build truly intelligent machines anymore, it's, with this incredible power now in our hands, what are we going to build next?